Hi, this is Josh. Today I wanted to spend some time working on simplifying radicals or square roots using the quotient property. Remember, the quotient is when you're dividing stuff. Okay, so I know that all sounds really technical, but it's not. So let's get through some of these guys. I wrote them over here for you today because I want you to try them on your own. If you want to watch me do the first guy, that's okay. And then if you want to jump ahead and do these, and I recommend that with all my videos. If you see me put a problem up here, then pause the video, work on it, try it, because even if you get it wrong, it's not like anyone's going to laugh at you. And even if you do, and if you get it right, then you can like give yourself a high five, right? So let's do this first guy. Square root of 3 over 4. Okay, well, the rules of division tell us, and the products and all that stuff, the quotients, tell us that we can bust this apart just like we are busting apart the ones that were multiplied together. Okay, so we can make this into the square root of 3 over the square root of 4. Now, it gets a little bit trickier when you do it this way, and you'll see why. It doesn't look as pretty or as clean, but I try to do them in two separate parts, just so I know what I'm working with. So we have the square root of 3 on the top for this guy, but I can't do anything with that, so I guess that's just kind of done. But on the bottom, I can make this guy into a square root of 2 times the square root of 2. Okay, now you might be saying, hold up, Josh, I know that the square root of 4 is 2. So why do I need to do all this extra work? Well, it's just good practice, okay? If this is the first time you're doing this, if you're just learning it, then it's good for you to understand this rule, because this is what's going to help you when it's not a perfect square, okay? When it's square root of like 315 and you're going, I don't know the two numbers that make that up. Well, now you're going to need to bust them apart. Okay, so yes, if it's a perfect square and it's 12 or under, then go for it, right? If it's a very easy number, it's a one that you know like super fast, then do it, right? But understand the rule as well. So when it comes to pulling out our doubles, I have a double, so it just becomes a 2. So the answer for this guy is just the square root of 3 over 2. Okay, remember, these are just expressions. We're not solving for anything complicated. We're not, putting this into something else. We're just learning a rule and then applying it to these types of problems. Okay, so let me erase this guy. Again, hopefully you've already worked through this next one following that same principle. If you haven't, pause the video, try this stuff on your own. You're going to learn so much more if you do these things on your own first and then check your work. Top guy over here, square root of 20. So this is where I said it kind of gets ugly. I'm just going to write it over here again, and I'm going to start working my way through the problem. Square root of 20 is, remember, you could do anything that's going to multiply to make a 20, you can use. So what makes a 20? We'll do 10 and 2. So we have the square root of 10 times the square root of 2. And we have what makes a 10? A square root of 5 times the square root of 2. Okay. Now I've had students say, hey Josh, do I need to write all these square root signs? Do I really need those for this type of problem? It's yes and no, okay? I'm going to say yes and no. If you're just learning this stuff, then I say it's good practice and good habit because it's reminding you that these are square roots all the way down. After a while, if you've been doing it, then you could probably leave all the square root signs out because you know what to do. And any numbers that are left, you know how you write them under the square root sign, you just know what to do. Okay, so I guess it's kind of a yes and no answer. Pull out our doubles, right? We pull out the doubles, okay? So what can come out? This is a double, square root of 2, square root of 2, so that's a 2, and I have a 5 left. Okay, so this is my answer, but this is just my answer for the top, right? And so now I can do, and again, I'm taking the long way just to kind of work through the whole thing because I don't want there to be too many questions after watching this video. The square root of 4 can be looked at as the square root of 2 times the square root of 2. Yes, it's a perfect square. Yes, you could say, oh, we already did that problem right here. It's already a 2. Come on, dude. Okay, but again, I want to show you how the work needs to get done. Okay, from there, can I pull out a double? Yes, it's just that. It's just 2. Okay, so this turns into 2 square root 5 over 2, okay? And you say, yes, I'm done. Awesome, move on. No, not yet. Okay, the goal of this is to simplify. Simplify, simplify, simplify. And remember, these things are getting multiplied together, okay? And the rules of division and multiplication say that when you have stuff that's getting multiplied like that, I'll just put a little dot in there to show that it's multiply. It's a 2 times the square root of 5. And if you're not sure, you want to check, I always recommend, put that in your calculator. Put in square root of, I don't know, depending on your calculator, put in square root of 5 times 2 equals, and see what you get. It'll be some crazy decimal. Then do square root of 20 equals, and the number you get here should match the number you get here. So 2 times the square root of 5 divided by 2 can be reduced, okay? And I made this kind of obvious in the way I wrote it. And hopefully you're seeing that a 2 can be reduced with a 2 because 2 over 2 is 1. And so all you're left with is square root 5 over 1, right? Right. Well, one more step. Because technically, okay, do you need to put it over 1? Do you have like 6 over $1? No, you just have $6, right? So you could, after this, write it as just square root of 5. Circle your answer so your teacher knows where it is, because this is a lot of work that's going on, okay? And you want to show your steps and then show your final answer. So working through it, we went from here to here. After we broke them apart, we reduced those because it's a fraction, right? So it's this divided by this, and these are multiplied, so I can fairly cancel these, and then that was all that was left, okay? Again, if you wanted to watch these first two and now you want to work on this guy on your own, then do it. I'm going to work on this guy right now. Let me erase all this. Again, if you're not sure, ask questions to me. Post a question. Watch my other videos, okay? This is really good stuff. You're going to need this if you're going to move into Algebra 1 or anything beyond that. These are really helpful tools that are going to help you learn how to work through complicated equations. Okay, I'm going to work on these separately. We have a square root of 32 and a square root of 50. I hope I have enough room. Okay, 32. What makes a 32? Well, there's a couple of different ones. I'm gonna do easy, 8 times 4, okay? Square root of 8 times the square root of 4. Yes, you could tell yourself, oh, it's a perfect square, it's gonna be 2, right? But if you don't wanna do that, that's okay. Let's keep going. This is the square root of 2 times the square root of 2. This is the square root of 4 times the square root of 2. And I can keep going, square root of 2 times the square root of 2. I'm hoping this is still on the camera so that you can see all my little guys down at the bottom, okay? Again, this is why it's important. Give yourself plenty of space. Make sure you have lots of room so you don't overcomplicate your own math problem. 50, I'll do 25 and 2. Square root 25, square root 2. 25 is a perfect square, but I'm going to take it one step further. Square root of 5 times the square root of 5. Awesome. Okay, let's work through this guy first, and then I'm going to rewrite it up at the top. Now, if you want to rewrite it at the bottom, whatever, do your own thing, okay? Let's get doubles. I have a double here, and I have a double here, and I have a square root of 2 that's still left, okay? I'm always big on showing that work, because if you can get this far, maybe you'll get partial credit on your test, okay? This guy, 50, I have a double right here, which gives me a 5, and I have a square root of 2 right there, okay? I'm gonna fill in a couple of those dots again, right? I already made one here, but I'm gonna make it super, super obvious, super, super obvious, super, super obvious, okay? And the reason is because I want you to start seeing that it isn't just numbers that can be simplified or reduced or canceled out of the top and bottom. It's also the square root signs that can be canceled or reduced or turned into one whole, okay? Do I have any 2's on the bottom? No, so I can't do anything with that stuff. But I do have a square root 2 and a square root 2. So because I have one of them on the top and one on the bottom, I can reduce that. And now I'm just stuck with that. I can't really do much with it. It doesn't reduce, so my final answer is just 2 times 2, which is 4, over 5. Okay? If you have any questions, send me a message, get in contact, do something, okay? Because this is really good stuff, and it's teaching your brain a different way to see these types of problems.